Hi, everyone. This is Kyle Welch with SDX Central. I want to thank you for joining today's webinar, Cloud Native for Telco, What It Is and Why You Need It, presented by Wind River. For today's webinar, we're joined by Glenn Seiler, VP of Product Management and Strategy at Wind River. Today's webinar, we'll be discussing the benefits of including Cloud Native as part of your strategy to future-proof your networks. We'll discuss steps to deploy a container strategy that spans from the core to the edge and into devices. And finally, we'll be discussing how to deploy a hybrid strategy to get the most benefit, even with varying circumstances. At this time, I'd now like to hand the presentation over to Glenn to start the discussion around Cloud Native for Telco.
Great. Thank you, Kyle. And good morning, good afternoon to everyone. Thank you for attending the webinar. First thing I'd like to do is just introduce Wind River. And I promise I won't spend a lot of time, but some of you might not be very familiar with Wind River, what we do. We've actually been in the software business for about 35 years, providing RTOS and embedded Linux operating systems to a broad range of industries and segments. Over 2 billion devices, as I said, across multiple industries. And over 20 of the major telecom OEMs are using Wind River products in some device or some part of their network. But in addition to telecom, there's also a number of automotive, aerospace, and space programs. The one thing I'd like to really bring to your attention here is that these are essentially edge devices, right? And so when Wind River looks at the network and we look at how to deploy cloud native solutions, we're really looking at it from a device and an edge upwards perspective, as compared to a perspective of the data center down. And one of the things that is common across all of those is that they're critical infrastructure, and these devices, these solutions have to be up continuously, and that's really what we provide and specialize to our customers, is to ensure that when it really matters, they can choose Wind River. Now, we're going to talk about cloud native and what that means to deploying your applications in a telecom network. And I thought it'd probably best to just, let's define cloud native. Now, this is not a Wind River or an individual definition. I have actually chosen a definition that is on the Cloud Native Computing Foundation, CNCF website. I think this is actually a really good definition. And the thing I like about it in particular is that it defines cloud native in terms of all the components. The microservice, which is the actual function that's being delivered, the service packaged in a container, and then the orchestration of those containers in a cloud environment. And the technologies around cloud native, our containers, the service mesh that deploys it, the microservices, the APIs, and the various components. Those comprise cloud native. Sometimes people just kind of equate cloud native to containers, but as many of you probably know, it's much more than that. And one other thing I wanted to just introduce you to is a lexicon from the Open Glossary project. And so that second definition, the definition of cloud native technologies, actually comes from this Open Glossary of Edge Computing. This is a project within the Linux Foundation Edge umbrella group, of which a number of different open source projects exist, such as Acrano, EdgeX Foundry, and so on. So I thought it was interesting, and I wanted to bring to your attention this glossary that you can use to really define and leverage common lexicon when we're talking about cloud native and other complex technologies. When we talk about cloud native, of course, containers are a big part of that. And I thought I'd just start with some analyst data, give you a little bit of a snapshot. You can see here that the blue line represents 2016, 2017, where containers are being used. And not surprisingly, the containers are predominant in the telecom and the IT. I think everyone knows that telco and IT are converging. Data center technologies are being leveraged. Common commodity software and hardware being leveraged into the network, and so it's not surprising that containers are being used predominantly in telco. But as you can see in the next 5 years, that's only going to continue to grow, and that the telco IT segment will have almost twice as much usage of containers as some of the other segments. But you'll see in banking and financial services is forecast to be a lot of container usage, as well as in government, retail, and others. Now, some of the use cases that we're seeing when we go out and talk to customers, when we attend some of the various venues and events, we see a lot of use cases, and in particular 5G. And we have a number of customers today that are deploying cloud and today mostly VM, but looking to migrate to containers, cloud vRAN solutions, as well as multi-access edge computing and virtual CPE. And really, all of these use cases have a fair amount in common, is that there has to be local compute, local processing at the edge, very high bandwidth and low latency. And of course, other than performance and low latency, there's critical requirements such as security and availability, because all of these are what I call critical infrastructure workloads that really cannot be down. And so reliability and availability at the edge is one of the critical requirements. But we're seeing containers start to come up in a lot more than just telco and 5G use cases. I'm really excited about some of the use cases that we're seeing in the transportation area. We have a number of engagements with customers that are looking to implement smart transit, train management, rail management systems, as well as shipping and autonomous shipping, putting clouds and edge clouds actually on boats. So there's a number of very interesting use cases there, as well as in Industrial 4.0, in human-machine interface, virtual programmable logic controllers, as well as digital twin. If you're not familiar with digital twin, that's essentially the mirroring or creating digital images of both the OT environment as well as the IT environment. And then other use cases such as imaging monitoring. So all of these different industries are looking at use cases for how they can move to a cloud native environment. So let's look at this and from a slightly different perspective. So you can see in the blue, these are really different edge locations, and you see a lot of different definitions for edge. There's the near edge in the telco environment, which is really your base stations, your multi-access computing. a far edge, which is really the on-premise and the stadiums and enterprises and things like that. All of this, we tend to call broad edge because it really, the edge extends from the devices itself all the way to the near edge. And there's a lot of different types of architectures that are deployed in these types of scenarios. And it depends on the use case, depends on the organization, what legacy they may have, and you know, what exact architecture they want to use. In some cases, a distributed architecture where each site may act somewhat autonomously. There may be a centralized cloud where most of the control functions exist in a central location in the cloud, or more of a distributed hierarchical type of architecture. But regardless of what the architecture is, or whether it's a near or far edge, the real benefit and the intent of moving to a cloud native environment is that you can deploy application workloads in containers across a heterogeneous environment, across different types of architectures, different platforms, all using your cloud native APIs and components. And so, you know, whether you're deploying, whether your landing zone for your container is a data center, whether it's the far edge or the near edge, whether the platform that you're deploying to is proprietary or open, it could be OpenStack or other open source cloud platforms, and you know, even whether you're using Kubernetes or not, doesn't really matter. You develop a container and deploy that using standardized interfaces, open container interface, the container runtime interface, and so on, that are defined by organizations such as the Cloud Native Computing Foundation and others. And then the benefit, of course, is that from a single pane of glass, you're able to deploy these containers out to any architecture, any platform, at any location with across the broad edge. So let's look at some of the benefits. We'll take an analyst perspective first. And so this is a survey that was done by Cloud Foundry. And I like the survey because it's, you know, it's pretty broad. But one thing you'll notice is that it's really kind of feature function specific. And so it really breaks down, you know, into specific features or functions, why people would want to use containers and a cloud native environment. But if you look at these functions and you abstract it up, you'll notice that there's really 3 or 4 categories or 3 or 4 topics within this. One of them is operations and deployment. So version control, spinning up in seconds, doing easy image updates. That's really about the management and operations of the containers in a cloud native environment. Then there's other ones here, such as the development can be individually preferred tool sets, portability running on all major distributions, and it really talks about topics such as DevOps. So when I go out and talk to customers, from their view, I see a lot of different benefits and reasons why they want to move to a cloud native environment, but you have to consider what their function is, right? So there's different personas. And when you talk to someone who is building infrastructure, they're putting together the servers, they're doing the cabling, they're putting the software platform on the servers. What they really care about is that containers in cloud native is a packaging mechanism that's completely abstracted from their environment. So actually the benefit to them is that they don't have to care about the specific workloads, what's in the container. They know that they'll be putting together a software hardware environment, regardless of whether it's distributed or centralized, that can support a container, that support a given workload. Now, if you're talking to an operations person who is actually responsible for the day-to-day management of a network, then they're going to be concerned about deploying applications very quickly, very easily, and consistently, and they don't care about the target architecture. So it's actually the inverse of the previous persona. They care about the deployment, the monitoring, the life cycle of the workloads themselves. And the ability, one of the key benefits is the ability to replace complex upgrades with more ephemeral updates, very temporary and transient updates. And then if you're talking to a developer, they probably have a whole different set of concerns and benefits for why they want to move to a cloud native or a container environment. Facilitating DevOps, right? And the ability to develop a microservice or a function, very easily, the testing, deployment, management of the applications, being able to design it once and deploy it anywhere, again, independent of the infrastructure. And of course, the fact that these containers and microservices are far more lightweight than a virtual machine, start up much faster, and use less resource. So this kind of discussion that I have when I'm fortunate enough to be able to go out and talk with service providers, OEMs, and it really does make a difference what the function or the role is that an individual group or person may have, depending on why they want to move to a cloud native environment. But they have challenges as well. And some of the key challenges that I hear about when I talk with customers is, first of all, complexity. And not everyone is a senior architect or developer, and navigating this broad spectrum of cloud native and container technologies, and quite honestly, there's a new project or a new technology popping up almost every week, and so the complexity is very difficult, and especially at the edge, because one size doesn't fit all at the edge. There's a multitude of different use cases. It's very rarely homogeneous like is in a data center. Now, one of the other complexities that customers often ask me about is the diversity, because they're looking at it from the edge. They're looking at it from the OT environment, from a factory floor, or from a customer premise, or an enterprise. And they want to bridge that gap from the OT environment and the IT environment. And as I mentioned, in OT, it really isn't one size fits all. And there's different ways to do zero-touch provisioning, address different architectures and software platforms. Cost is something that doesn't really get discussed enough, but there's, I think, often a perception that you want to move all the applications to the edge because it'll have faster response and better bandwidth and so on. And also from an OpEx perspective, if you can move applications to the edge and then implement low touch or zero touch provisioning, then you reduce your OpEx costs because you don't have to send maintenance out to the locations and you lower those costs. But what a lot of people don't consider is the capital costs, the hardware that is required. If you were to move all your data center functions, and I'm not suggesting that people do, but to give an extreme example, if you were to move all your data center functions out to the edge, and there was literally hundreds or thousands of locations, the hardware costs, the cabling, the power, the cooling in some cases would be considerable. And I've talked to some OEMs who tell me that for every application they want to move out to the edge, it costs them 5 times more in capital costs than it would to manage it in the data center. Now that's especially true if you have traditional data center architectures where you may have 3 controllers to manage a cluster to ensure high availability and other things. And so you can see that can quite easily get expensive very quickly. So one of the things that when you're looking at deploying an edge, a cloud native solution, is minimizing that hardware, hyper-converging control, compute, storage down to as small a footprint as possible. And then finally, security and performance of containers. Can't forget the importance of security and performance. So these are the 4 areas. And what I'd like to do next is switch over to talk about how we can start to address these types of solutions or requirements. Some of the critical requirements that we hear about is workload orchestration. So really determining where and how an application workload can be processed. And oftentimes this is in a multi-tier gradient of compute, storage, network resources. Zero-touch provisioning, which of course is a way to manage workload orchestration, is really about an automated system that will take into account the performance, the time, the cost requirements for automating the deployment of workloads. Centralized management in some architectures, which provides a system-wide view of all the servers, all the devices from a single pane of glass. And these could be centralized services such as logging, storage, security, and so on. But you also want edge autonomy. And so what I mean by this is if connectivity is lost between the edge servers and the central site, the edge cloud or the edge server needs to have enough of a small control plane to be able to continue to perform its mission critical functions until such time as the central site can be reconnected. And of course, massive scale, from literally tens to hundreds or thousands of devices, often very geographically dispersed. So this is a little bit of a diagram of really what I just described. Oftentimes you have an in-tier or multi-tier architecture, a distributed control plane. You may have regional edge servers and then edge worker nodes that are actually performing the workloads. Oftentimes these are OT-based workloads in factories, managing transit systems, as I mentioned, or autonomous vehicles and all types of different use cases. And really where the workload exists will oftentimes be dependent on what the latency requirements are. And so, very, very low latency, such as 5 milliseconds and up to 20 milliseconds, you're going to want the application or the workload to be as far out on the far edge as possible. Whereas, latencies that aren't quite as restrictive, 50 milliseconds or so, maybe you have regional edge servers. As you go further out to the edge, you're going to want to have a smaller footprint to address the cost issue that I mentioned earlier and the overall overhead. So what I call a thin control plane, the further out that you go to the edge, with more centralized services in the central control plane or at the region. And then being able to manage zero-touch provisioning from a single pane of glass, whether it's to the edge controllers or to the actual edge worker nodes themselves. So this is a type of topography, distributed cloud topography. I'm going to talk a little bit about in the next section when I go into actual implementations. So we've talked about the benefits, the challenges of a cloud native environment. Hopefully, you know, why we want to move to cloud native. There's lots of options. And one of the things that you have to, you know, be cognizant of is, you know, what's the legacy environment? And there's a big investment in virtual machine architectures, you know, hypervisor architectures, OpenStack, and so on. So, you know, you can't just throw that away and move to a pure cloud native environment. And what we're seeing is a lot of different options. And so I'm going to mention a few of these based on my experience as I've engaged with different customers to move from a VM to a container-based architecture or cloud-native architecture. So one of these is putting the container in a VM. Now, I know that there's some people I've talked to frown on this because it's, you know, it's a hybrid. It can be a little slower than native containers. But there's actually some really nice benefits to this architecture. So first of all, it enables an organization to maintain their investment in existing architecture if they already have a hypervisor-based, VM-based architecture. But they are able to take advantage of containers, of being able to use application-specific, you know, container APIs. They can still develop their containers using a DevOps type of environment. There is a container orchestration engine, you know, Kubernetes or Mesosphere or whatever orchestration engine they want to use, and they can access and manage the containers using that container environment. So they have those benefits of the container interface, the container orchestration, but they still are able to leverage the virtual machine hypervisor infrastructure that they have in place. The other thing that I like about this particular architecture is that a lot of these hypervisor, these virtual machine architectures, there's a lot of investment in maintaining the virtual machine, what I call you know, keeping it alive. So there's live migration, monitoring, fault recovery, and other types of services that are very mature for a virtual machine environment. And you're able to continue to leverage these and apply it to the container as well. So this is a very interesting hybrid architecture. Now, the one thing about this architecture I'll also point out is that this is a single compute node, right? So this is a single worker node using a hypervisor that can run either a container or a VM. Now, the downside, as you might see, is, of course, there's a lot of moving parts here, right? You've got OpenStack going, you've got the hypervisor, you've got the container engine, and it can be a complex environment, but it allows you to maintain an existing investment and move to containers. Now, slightly different of this is the bare metal containers in a VM architecture. So this is really using the OpenStack Ironic technology, as well as some other OpenStack services such as Magnum. Now, the difference here I want to point out is that these are actually two separate nodes. You have bare metal nodes without a hypervisor, that can run Ironic and run your containers and support your container engine, or you can have compute nodes using traditional hypervisors. So this is kind of rather than a hybrid mode, I'd call this a dual mode, where you can run either containers in an Ironic instance or VMs in a traditional Nova hypervisor environment. This is a pretty flexible and proven method. Ironic's been around for a while. There's a lot of deployments that use this type of solution. The containers run natively. There's no hypervisor. They can be managed by a container engine, but yet you can continue to maintain your investment in VMs and OpenStack. Again, it's a little complex. It's a little heavy it's a little heavy control plane for the edge. But nevertheless, a very viable solution that I see a lot of customers looking at today. Now, the third option is actually taking the OpenStack services and containerizing them. And so this kind of flips it around so that the container environment is the primary architecture. And when necessary, if you have a VM, legacy VM solution, you can deploy that using OpenStack services. You don't have to rewrite the applications, and you deploy OpenStack in containers. So this would be on top of a bare metal Kubernetes cluster. The VMs and the containers are managed the same way, right? So you use Kubernetes rather than OpenStack to manage the VMs, and they're deployed in containers. You only run the OpenStack when you have a need for the legacy solutions. So I see this type of solution really a lot of interest, more for 5G and newer applications, newer use cases that you have the benefit to, basically build a new platform. So these are three of the architectures. By no means are these the only options or architectures available. And of course, there's probably a lot of variants to these three types. So let's consider that you want to build your own cloud native edge cloud. Where do you start? Well, there's a lot of foundations and open source projects that are out there that you can take advantage of. The Cloud Native Computing Foundation, of course, is the place where a lot of the APIs, the cloud native components are being developed, and obviously that's a source for your technology. There's organizations like the Linux Foundation Edge, and specifically the Acrano work group, where they're defining architectures and solution stacks, end-to-end solution stacks that address specific use cases at the edge using these technologies from the Cloud Native Computing Foundation, as well as technologies from OpenStack. And two of the technologies that I want to mention real quick are the Starling X project and the Airship project. And both of these are addressed to provide containers and cloud native solutions at the edge. So what I'd like to do next is run you through one of these projects and how it's addressing a lot of the requirements and challenges that we talked about earlier in the session. And to do that, I wanted to stop and have a polling question and see how many of you are actually familiar with the Starling X project. Have you, if you've ever heard of it, if you know about it, but you haven't really looked at it, maybe you actually understand it pretty well, and some of you may have actually downloaded it and installed it. So I'll just give a moment here to give everyone a chance to fill it out.
And Glenn, this is Kyle again. Yeah, we're just going to leave the poll open for about 20 more seconds here. So please go ahead and submit your vote, and then we'll go ahead and close it out. Okay, we're going to go ahead and close out the poll and then share the results right here. And Glenn, looking at this, is there anything surprising, anything really stand out here from your perspective?
Not really. And although, of course, I'd like to think that more people have heard of it, but it's not really surprising. Starling X is a relatively new project in the bigger scope of open source and cloud native. It's been around for less than a year. It was launched at the OpenStack Summit in Berlin last November, and so it doesn't surprise me that 60% of the folks haven't heard of it yet. I'm actually encouraged that there's a 38, almost 40% have at least heard of it and know of it, and some actually that understand it pretty well. So that's actually encouraging. And what I'd like to do is now talk a little bit about Starling X. And I think I have to request control here again. Okay, here we go. I want to just show you a diagram of Starling X and the architecture. So if you recall just a few minutes ago, I showed an architecture that had a Kubernetes platform, container-based platform, and then it was running OpenStack services in containers. So that's really what this is showing here. It's a pretty complex block diagram, I understand. But what Starling X provides is essentially a pre-built distribution, and by pre-building and integrating all of these different cloud native and OpenStack technologies, it addresses some of the complexity, which, if you recall, was one of the key challenges that customers had. So it's pre-built, it's pre-integrated, and essentially a cloud distribution, edge cloud distribution ready to go. It's a container-based architecture, but it supports the use of VMs when required as I mentioned, by containerizing OpenStack and running the VMs in the containers. It has the flexibility that's designed for an edge type of use cases, and I'll go into more detail on that. And the really interesting thing is that it can scale from a single server, hyper-converged control plane, compute, and storage into a single server. So that's going to address the cost requirement that we showed earlier. One of the challenges was the cost of deployment. Now, in addition to standard cloud native container services, Starling X also has a number of infrastructure services for things like fault management, service management, host management, so it can do fault detection, monitoring, and other types of services to ensure high reliability, zero-touch provisioning, ease of management, and those types of services. Now, I mentioned very briefly that it can provide that small footprint from a single server up to a micro data center. And I've talked to a number of customers over the last 6 months or so, and I've seen everything from customers wanting to deploy just a single server at the far edge. Most of the time, what I am asked about is, well, how can I provide reliability or availability? So providing a dual server with protected pairs, it's essentially a one-to-one protected pair or redundant server. So in the case that one fails, so you actually have control-to-control fault management. So you can, if the control function or the compute function fails, you can fail over to the other server. But then I also talk to customers who want to deploy, actually little mini data centers at the edge, in containers, on ships, in different remote locations. That could be a full rack or sometimes even more than a full rack. The nice thing about Starling X architecture is that it enables all of these different configurations. And then finally, one of the capabilities that the Starling X project is working on is what I call the next generation distributed cloud. This is a work group or a sub-project within Starling X, and what they're really working on is this N-tier or multi-tier hierarchy that I described earlier in the session, where you have a central controller, a regional controller that provides a lot of the key management functions, such as monitoring, logging. This is where you would provide the software updates, the zero-touch provisioning, and the Kubernetes master components. By doing this, you're able to keep a large part of the control plane centralized, so that you can have a much, much smaller control plane, only what's necessary at the regional edge. And it could be that you have VMs and you need to orchestrate and manage VMs, or it could be that it's a pure cloud native controller and you have a Kubernetes master nodes. And these are all connected via lightweight management network, a L3, if you will, network. And if the connection breaks for whatever reason, these nodes would be able to work autonomously until the connection could be reestablished. So this is a distributed architecture that the Starling X project is working on, that really solves some of the critical problems at the edge, provides a low-touch provisioning from a single pane of glass, could deploy VMs or containers equally, and be scalable from a single node to thousands of end nodes. So this is really the, I think one of the exciting and new open source projects and alternatives that you have when you're considering how you want to start deploying, implementing edge solutions. And then finally, just a word about security. Don't want to forget security. Now, we could have a whole webinar session just on security. But I do want to mention that the way that we're really looking at security is that it isn't a single, security isn't a single thing. It's really multidimensional. You have to look at security from the hardware and the silicon up, by providing a secure chain of trust from the physical hardware up to the virtual machine or container. You have to look at security through the platform with technologies or capabilities such as trusted platform management and network authentication, authorization, and those types of capabilities. And then you want to look at it from the top down or the network in, with capabilities such as firewalls and other operational and management capabilities. And then on top of that, comprehensive security services that address policy enforcement, detection, intrusion detection, and other types of services. So really you have to look at security from a full perspective. And as I said, this could be a whole session on itself, but these are topics and capabilities that are being looked at in the context of the Starling X project. I'd like to summarize and wrap up so we have a little bit of time for Q&A. Operational complexity is really the biggest challenge for how to move to a distributed edge. The fact that it isn't one size fits all, there's multiple architectures, multiple platforms, trying to address the provisioning and the orchestration is a very complex issue. And these new distributed edge clouds really are intended to support centralized management, edge autonomy, and ZTP. And you can see that really cloud native standards from CNCF and other places are what's going to help drive this. Now, if you're interested in getting more information, I hope this has been informative. And if you do want to get more information, I encourage you to go to Wind River's website, where we have a white paper on the distributed edge cloud, what we're doing to contribute to Starling X, and really use that architecture for a commercial distributed edge cloud. Or I encourage you to go directly to Starling X at www.starlingx.io, join the mailing list. You can download the binary. You can look at the project onboarding, the documentation, or contact anyone at Wind River to see more about what we're doing with Starling X and how we're using Starling X to provide commercial cloud, edge cloud platforms. With that, I would like to hand it back to Kyle and see if there's any questions.
Yeah, Glenn, we had a number of questions that came in. Before we did that, I just want to alert everyone that if you look in the chat function, we have all the links that Glenn had in his presentation for you. And then also we will be sending you a copy of the slides here probably sometime tomorrow, so you can follow up with those directly. All right, with that, let's go ahead and jump in with some questions. So Glenn, first one we got in. So on one of your slides in your presentation, you walked through Starling X and Airship, and you touched on this briefly, but could you give a little more about the difference between the two?
Sure. So first of all, both Airship and Starling X are OpenStack pilot projects. They both kicked off last year. Airship is specific about providing a provisioning platform, a container-based provisioning platform that is very declarative, uses YAML files, and really helps provide the provisioning of the platforms. I'm sorry, the provisioning of the containers to the edge. It's platform independent, and what I mean by that, it could run on any Linux operating system. It really provides just the orchestration component or management component and provisioning. Starling X, on the other hand, is more of an end-to-end platform, a distribution. So it includes the Linux operating system, it includes the storage, Ceph for storage, it includes some of the high availability services, as well as the container provisioning capability. And in fact, Starling X uses one or two of the components from Airship, Armada, and some of the other Helm and Armada to do the deployment. So there's a little overlap, but I think the the primary difference is, Airship is very specific to the provisioning. Starling X is more of a distribution out of the box. Those are the primary differences.
Got it. Thanks. So next question we had come in is, previous in your presentation, you talked about Starling X as an OpenStack project, but is OpenStack more about VMs and not cloud native?
Well, traditionally, I think that's the perspective that people have about OpenStack. But actually, you might be aware that recently OpenStack is changed from the Open Infrastructure Summit, and so they're really looking at a much broader set of services and projects. And as I mentioned, Airship and Starling X, both of which leverage containers, are part of the OpenStack foundation. So you're really seeing OpenStack broadening its scope much beyond just the traditional VMs, to really be a broad set of open source projects and services. It also is doing some interesting things with CI/CD and the Zool project. So it's really expanding considerably beyond just VMs.
Thanks, Glenn. We had a question come in for just a point of clarity. So on slide 20, when you were talking about containers and a VM architecture, what does COE stand for?
Sure, that's the Container Orchestration Engine. And so essentially that is a Kubernetes or some lightweight orchestration engine for containers.
And then another question came in this is in reference to slide 18 when you were talking about distributed edge cloud topography. Have you seen any sort of use case or advocacy around blockchain when it comes to distributed edge for cloud topography?
Oh, great question. Yes, I'm seeing that. Now, I don't have a really specific use case that I can point to. What I can say is that I was at Mobile World Congress a couple of weeks ago, and blockchain and Hyperledger were everywhere. And companies like T-Mobile were talking about how they're using Hyperledger in particular, but blockchain technologies to manage deployments and in certain use cases. So I am actually starting to see that quite a lot. And there was a lot of topics at the Open Source Leadership Summit last week around that topic as well. I don't have specific use cases that I could point to, but I know that there's a tremendous amount of interest in that right now.
Yeah, no, thanks for addressing that. That was great. So it looks like we have time for one more question. So some of the use cases you mentioned in your presentation, they require security, and some seem to have safety certifications required. How does a cloud native solution like the one you described handle all of this?
Okay, so that's a pretty complex question, but it goes back to the concept of OT versus IT that I talked about earlier. And so these certifications, so in the case of autonomous vehicles, for example, or factory automation, there could be safety certifications that have to be built into the workload. And what is really going to be required there is a solution where you can deliver a secure, certified workload to a device or a server, and not have that be impacted by other workloads in that environment. So you're talking about isolation and security. And so these are actually some of the topics and capabilities that we're looking at addressing as we scale out into OT environments. This is actually something that Wind River's working on because we do a lot of safety certifications in a lot of different segments. And the key thing is that you need to be able to isolate those applications and deliver them securely. What makes it a little more complex is if you want to have a hybrid environment where you're running more general purpose applications together with these secure applications or safety critical applications. So I would encourage anyone who has that particular requirement or use case, please talk to us at Wind River. We've got some really interesting solutions that we can discuss.
Okay, perfect. That's about all the time we have for today's webinar. I want to thank our presenter, Glenn Seiler, VP of Product Management Strategy and Glenn Seiler, VP of Product Management and Strategy at Wind River. Glenn, thank you for joining us today.
Thank you very much.
And I also want to thank all of our attendees today for joining today's webinar, Cloud Native for Telco, What It Is and Why You Need It, presented by Wind River. Thank you all.